Hey everyone, I'm Siddharth and this is Sciencefully. Today I actually have a fun little experiment in store that you can also do at home. It is based on something called the Leidenfrost effect. But more on that later. First, the demonstration. All you need for this to work is a pan, a source of heat and a few drops of water. First, heat the pan to about 100 degrees centigrade. Now, sprinkle a few drops of water on the pan. They evaporate. Obviously, it's what was expected. Now let's heat the pan further. Over 200 degrees now. Let's try again. What is that? They dance around instead of evaporating. But why is this happening? I mean, the pan is clearly way hotter than the boiling point of water. Then how is this actually possible? The temperature, it turns out, is actually the key to this effect. Here's why. So when the droplet touches the blistering pan, the bottom part of it evaporates instantaneously, creating a kind of cushion on which the droplet floats. Now, water vapor is a really bad conductor of heat, so it insulates the drop and it never reaches the boiling point. Let me point out that this floating drop of water is not immortal. It will evaporate completely, but it certainly lasts a lot longer than it normally would at a pan that was cooler. The temperature at which this drop lasts the longest is called the Leidenfrost point. Alright, why doesn't this work at cooler temperatures? Well, the bottom part of the drop reaches its boiling point due to the flow of heat. Heat flows from the hotter body, in this case the pan, to the cooler body, the water droplet. This rate of flow of heat per unit time is also known as heat flux. Heat flux is proportional to the temperature difference. So if the temperature difference is greater, more heat is transferred quickly. For example, take a very cold drop of water and drop it on a pan at 110 degrees. Well, the temperature difference is certainly large, but it is a mistake to assume that the Leidenfrost effect would set in. The initial heat flux would be high, but as the temperature of the drop approaches its boiling point, the flow slows down. At 90 degrees, it would be a lot slower because the temperature difference is a lot less. In this case, the bottom part of the drop takes too much time to evaporate. By this time, the rest of the drop already reaches the boiling point. This effect was observed by German doctor Johann Gottlob Leidenfrost. He published it in his book, A Tract About Some Qualities of Common Water, in 1751. This effect is also the reason behind many demonstrations of people dipping their fingers in water and then in molten metal. Some of the water evaporates and then insulates, but this is still mighty dangerous to attempt. The hand must be pulled out quickly enough because otherwise all the water will evaporate and so would the fingers. Remember, the drop is not immortal. The vapor only slows down the transfer of heat. It does not entirely eliminate it. And that is the reason behind dancing water drops. It's not magic, it's just science, as it always is.